Okay, so page 4 on your journal is the triangles classification page. And once you've decided that you have a figure that is a polygon, meaning that it is closed, there are no curved lines, and there's no cross lines, you've got a polygon, so you're going to look to the number of sides it has. If it has 3 sides, then it is a triangle. So triangle are 3-sided polygons that can be classified 2 different ways. So there's 2 different classifications for triangles, and one of them is the angles and the other is the sides. So the first classification for angles we're going to start with over here, and that is a right triangle is a triangle that has only one angle that measures 90 degrees. You will usually see this indicated by the little box in the corner there. Sometimes you might just have to look at it and say, is that exactly a sharp 90-degree corner? Or it might be labeled with the number 90. Either way, if you see that there is one 90-degree angle in the triangle, it is a right triangle. The next is an acute triangle. And in an acute triangle, all 3 angles are less than 90 degrees. So you might have 60, 60, and 60 labeled. You might just see that they're all narrower than 90 degrees, and in that case you know that you have an acute triangle. And last is an obtuse triangle, and an obtuse triangle has only one angle that measures more than 90 degrees. So if you look at this triangle here, it might tell you that this angle is 100, this angle is 40, and this angle is 40. So because there is just one obtuse angle, that means it is an obtuse triangle. That is important to remember because it is very important to also know that the sum of all angles of a triangle will always equal 180 degrees. If the sum of the angles does not equal 180 degrees, it's either not going to close or you're going to have lines that cross and then you don't have a polygon anymore. So if you have a question that tells you that these two angles are labeled, you know, this is 100 and this is 40, you're going to be able to figure out what is the third angle because you know that when you add them all 3 together, they need to equal 180 degrees. Okay, so moving over to sides of a triangle, this is the second way that we classify them, and that is the length of their sides. So equilateral triangle is just what it sounds like. All 3 sides are equal length. And that can be indicated with either hash marks, meaning if I've got one hash mark on each one of those sides, that's telling you that all 3 sides of those triangle are equal length. It also might just tell you with the label exactly what the length of those are. It might say this is 2, this is 2, and this is 2. Okay, an isosceles triangle means that at least 2 of the sides are equal length. Or congruent. Congruent is another word for equal. And again, this might be indicated with the hash marks, showing 1 and 1 here means those 2 are equal length. But let's say you've got 2 hash marks on this side. That means that this side is a different length than those 2 sides. Or again, it might just be labeled with numbers. Maybe this is 5, this is 5, and this is 3. Those 2 sides are equal, so it is an isosceles triangle. And a scalene triangle means that all 3 sides are different lengths. So if you have hash marks on it, it would look something like that's one length, this is a different length, and that one's a different length than the other two. Or again, it could be labeled with numbers. Maybe this is 12, this is 10, and this is 8. All three sides are different lengths. It is a scalene triangle. Okay, so the next page of your journal notes is not really a notes page. This is page 5. It says Classifying Triangles Checklist. And this is more of a tool that you can use when you are classifying triangles. So you know that triangles have to be classified by sides and angles. So you can use this to decide what they are. And you can choose angles or sides, doesn't matter, whichever one. Let's say you're looking at a triangle figure that shows you something like this. Okay, so you're going to look at it first. Let's say we're going to look at it by angles. We're going to first ask yourself, is there at least one right angle on this triangle? And I don't see one right angle, so I'm going to go to the next classification. Is there one obtuse angle? I don't see another angle. Again, I don't see an angle here that looks like it is wider than 90 degrees. So my third question is, are all three angles acute? And yes, these all look like they are more narrow than 90 degrees, which means that I can stop there. I know that this triangle is acute. But that's not the only name for that one. Now I have to also label it according to length of the sides. So if I look here, I'm going to say, are all sides different lengths? This one's not labeled, but we're going to go like this. So are all sides different lengths? No. So I know it's not a scalene triangle. I'm going to go to the next option. Are two sides equal lengths? Well, this side and this side are definitely equal lengths, so I know that it is at least an isosceles triangle. But I can go one step further and say, are all three sides equal length? And they are. So this is acute and equilateral. Which is the most specific description of this triangle, but because there are three sides that are equal, it is also an isosceles triangle. The best answer would be acute equilateral, but acute equilateral and isosceles would also work on that triangle. Give you one more example. Let's say you have a triangle looks like this. Looking at from the angles side, are there any right angles? No, it doesn't look like there are any right angles that are indicated here. Is there one obtuse angle? Yes, this angle right here looks like it is wider than 90 degrees, so I'm going to stop there and I'm going to say this is obtuse. And then I'm going to look at the side lengths. Are all sides different lengths? Judging by the hash marks, I've got 1, 2, 3. Yes, those are different. So this is going to be labeled an obtuse scalene triangle.